Hello guys, my name is Hexadecimal. Welcome to my Facebook page. Please follow my page so that we reach as many viewers as possible. Alright guys, so back into the business of the day. So like I promised in the first video that I made, right, I'm going to be channeling out or parceling out what we have in the computer science IGCSE syllabus. So in chapter 1 basically it's all about data representation. So data representation is all about how computers read the data. So this data can be instructions that we provide onto these computers in our day-to-day lives. So as you all know, or maybe you haven't heard of this, right? Because it's easy for us to just type things on the keyboard and then you see them appearing on the screen. But a lot of things, a lot of processes would have occurred in the background there, because a computer does not understand A, does not understand 1, does not understand either of the characters and numbers that we use to give instructions to it. So all these characters, numbers and so forth, they have to be converted into machine code. So machine code, we are simply talking about zeros and ones. So for this to be done, maybe before we go there, numbers are converted into binary, right? Binaries, we are simply referring to ones and zeros. Letters are also converted into binary, and sound can also be converted into binary, as well as pictures. They can also be converted into machine readable language. So what we have in the first units of chapter 1 is all about how to convert denary numbers into binary numbers, right? Denary numbers. So these denary numbers, we are simply referring to natural counting numbers, the ones that you know. So they have to be converted into binary numbers. And again, we are supposed to be looking at how to convert from binary into hexadecimal, which is another form of a number system. So simply hexadecimal, it is just a base 16 number system, and then binary number, it is a base 2 number system. So there are various ways that we can use to convert these numbers from denary to binary, from denary to hexadecimal. So there are two ways that you can use to do that. So the first way of converting denary number into binary is by using the binary units. You have to know the binary units which you're supposed to use when converting any denary number into binary. The second method is by successive division by 2, right? We have to do successive division by 2, then we take the remainders from bottom to top. And then the last method, converting from denary to hexadecimal, right? The first method, we can use the binary units as well. We can use that. In fact, the first method, we can first convert from denary to binary, and then from binary to hexadecimal. That would be very easy. And then the second method, we can use the successive division by 16, because hexadecimal is base 16 number system. So this is how we represent numbers, how we convert numbers from denary form into binary, as well as into hexadecimal. We can as well convert back from binary to denary, as well as from hexadecimal back to denary, right? So for detailed explanations and workings on this, please you can hit my inbox, or you can contact me on the numbers appearing on your screen, so that we discuss. I'm available in Facebook for online as well as in-person lessons. So generally I'm in Western Cape, but distance again is not a barrier. Even if you're in Zimbabwe, Angola, Malawi and so forth, we can do online lessons, right? So that's the first part. And again, the second part is all about logical shift, right? Logical shifts and addition of these binary numbers. So if you want to do addition of binary numbers, you need to know simple 4 rules. So the first rule is 0 plus 0 is equal to 0, 1 plus 0 is equal to 1, 1 plus 1 is 0 carry 1, and 1 plus 1 plus 1 is 1 carry 1. So if you know these rules, it will be easier for you to do binary addition. And then logical shift. In logical shift, we can either do a shift to the right or to the left. So when you are doing a shift to the right, you are creating an empty space to the left. When you are doing logical shift to the left, you are creating an empty space to the right. And all these empty spaces would have created in the registers, then we would simply have to use zeros, right, to write zeros as placeholders, so that we maintain the number of bits. If it is an 8-bit, after any shift, it should remain as an 8-bit binary number. So that is what we do. And converting images to binary, we use there are various methods that we can use. And again, I want to talk about converting text, right? Converting text to binary. So in this case, we use an instruction set, and in this scenario, the instruction set we are referring to is the ASCII table, right? The ASCII table. So it has got all the characters, the numbers, the letters, and so forth. Whatever that we find on our keyboards, right? It's there, and their respective denary values. So sometimes it will be up to you as a student to convert these denary numbers into binary, or sometimes you can get an ASCII table which also has got all the values, including the binary equivalents. So in brief, this is what we have in chapter 1, and on the next video I'm also going to be discussing about compression. There are two types of compression, which is lossy and lossless compression. So I'll just be giving a brief explanation of what is this. So please follow my page, right? You can also contact me on the numbers appearing on your screen, so that we discuss on whether we can do lessons online or face-to-face. So I'm based in Fishhook, like I said, I'm based in Fishhook, Western Cape. So for online lessons, distance is not a barrier. We can do wherever you are. We can do online lessons using Zoom, Google Meet, or whatever platform that you're comfortable with. And for face-to-face, I can come to your place of residence so that we do lessons. Please like, share, and subscribe. Computer science is the future. Let's embrace ICT. Let's embrace computer science. Thank you very much.